Hey everyone, welcome Class 8 students and all our new recruits to your first official day in the Data Science Squad. I'm absolutely pumped to be your guide today as we decode the digital world around us. In this explainer, we're diving headfirst into the complete Chapter 6 curriculum. We're going to break down exactly how data powers, well, pretty much the entire modern world. So are you ready to become a full-fledged data detective? Let's jump right in.
So, have you ever actually wondered how your GPS magically knows the exact traffic conditions to get you to school on time? Spoiler alert, it's not magic. It is data. Mapping apps collect just a massive amount of information. We're talking satellite photos, traffic sensors, and even the motion of other users' phones out on the road. By crunching all of this, you get real-time traffic updates and the absolute fastest route. It's really the perfect example of taking raw data and turning it into something we use every single day.
Here is your detective training syllabus for today's explainer. The domains of AI, decoding data and forms, sorting qualitative versus quantitative, measuring continuous versus discrete, the data science lifecycle, and finally, real-world data applications.
Section 1. The domains of AI.
Artificial intelligence actually relies on three main domains. First up is computer vision, which essentially lets machines process visual inputs, like pictures, just like we do. Second is natural language processing, which is what allows machines to understand human language. But the third one, and the one we are completely laser-focused on today, is data. Data is literally the foundational fuel that powers the whole operation.
Section 2. Decoding data and forms.
Okay, so before we go any further, we need to understand what data actually is at its most basic level. At its core, data is just raw facts, concepts, or instructions stored on a computer's hard drive entirely in binary form. That means all of this incredibly complex information is represented using just two states, 0 and 1.
Now, thankfully, we don't have to sit around reading endless screens of zeros and ones. The computer actually converts that binary data back into formats that we can easily understand. This includes text, like articles, websites, and books, audio, like your favorite songs or the news, images, which covers pictures and scanned documents, and of course, video, like movies and those online YouTube lectures.
Section 3. Sorting, qualitative versus quantitative.
If a computer is going to process information, it needs to know what kind of information it's dealing with. So we divide data into two main buckets. On one side, we have quantitative data. Think of the word quantity. This is data that is countable, it's represented by numbers, and it answers questions like how many or how much. On the flip side, we have qualitative data. Think quality. This data is descriptive, usually represented in text, and answers questions like why, what, and how. You collect this by observing things, not measuring them.
Let's put that into practice. Saying Rahul weighs 43 kilograms, or the temperature is 24 degrees, or the distance to school is exactly 1 kilometer. Those are hard, countable numbers. That makes them quantitative. But if you say your sister has brown eyes, or your friend is a really good singer, or the teaching style is great, those are descriptive qualities. So that's qualitative data.
Section 4. Measuring, continuous versus discrete. Let's zoom in on that quantitative number side of things, because it actually splits again into two distinct categories. First, we have continuous data. This is numerical data that isn't fixed. It can literally take any value between two numbers. Then we have discrete data. This involves finite, fixed numbers that cannot be divided into smaller parts. Think integers or whole numbers. To really wrap our heads around this, imagine a company that sells refrigerators. If they sell 300 fridges in a month, well, you can't sell half a refrigerator, right? So that count is a fixed, discrete number. But the temperature inside those refrigerators, that's a different story. It might range between 10 and 38 degrees Celsius, and it could be 10.5 or 36.2. Because it fluctuates and can be broken down into infinite decimals, the temperature is continuous data.
Section 5. The Data Science Lifecycle.
Working with all this data isn't guesswork. Professionals follow a very strict 5-step lifecycle. Step 1 is capture, gathering raw data from reliable sources. Step 2 is maintain, cleaning that data up so it's in a nice, consistent format. Step 3 is process, organizing it to find hidden patterns. Step 4 is analyze. This is where AI and machine learning step in to generate actual insights. And finally, Step 5 is communicate, turning those complex findings into visual graphs and reports so people can actually understand and use them.
And the real heroes driving this entire 5-step process? Data scientists. A data scientist uses various tools, algorithms, and AI models to analyze data, find patterns, and help organizations make informed decisions. They do the heavy lifting of preparing and processing all those clues. It is honestly an incredibly exciting career path that is shaping so much of our future.
Section 6. Real-world data applications.
You probably interact with data science every single day without even realizing it. When you watch a video on a streaming platform, it analyzes your history to recommend what you should watch next. Social media uses data to suggest friends. Booking platforms use it to suggest flights. Businesses even analyze customer demand to figure out exactly how to price their products. It is constantly operating right behind the scenes to make our digital lives seamless.
But it's not just about convenience. It is a major player in security, too. You've probably heard about different types of financial fraud in the workplace. Well, by continuously monitoring and auditing data science algorithms can actually automate fraud detection. It helps companies spot anomalies and defeat complex financial frauds before they do major damage.
All right, you now have the foundational knowledge of a true data detective. You know the domains of AI, the types of data, and the professional life cycle. So it is time to put your new skills to the test.
Your mission is to jump into the computer lab and play a computerized version of rock, paper, scissors. But here's the twist. This isn't just a random game. It's powered by AI. The machine is actually attempting to guess your next move by learning from your past plays. It is actively capturing, maintaining, and analyzing your gameplay data in real time right there in front of you.
So, now that you know exactly how the system captures and processes both qualitative and quantitative data, I have a challenge for you. Can you outsmart the AI? Can you randomize your patterns enough to totally disrupt its data science lifecycle? I highly encourage you to give it a try and see firsthand just how powerful data really is. Thank you so much for joining me on this explainer, Data Science Squad. Stay curious and keep analyzing.